So thank you for joining us at this series of seminars at the Institute of Computing at University of Campinas in Brazil, in partnership with the Catholic University of Rio de Janeiro in the beautiful city of Rio de Janeiro, Brazil. Today, I have the honor to host here Professor Philippe De Wilde. He is going to talk to us about small artificial intelligence versus big artificial intelligence. And I would like also to thank my colleague, Professor Leopoldo, who made this arrangement for Professor Philip to talk to us today. Professor Philip is from the University of Kent, UK, and he's a professor of AI in the Division of Natural Sciences at this University of Kent, United Kingdom. He promotes the use of AI and machine learning in biosciences, medical science, and physics. He works in the context of digital humanism on transparent and humane AI. So this is part of our interest in discussing the political, philosophical, sociological, and all of the environmental impacts of AI here in our lab. And Professor Philip is more than adequate to discuss with us these topics today. I will also thank Professor Marcos from Catholic University of Rio de Janeiro, who is partner in this series of seminars. Professor Marcos Sandler, thank you for being our partner during these last 2 years in this series as well. So, Professor Philip, once again, thank you very much for accepting the invitation. The stage is all yours. I will be in the background in case you need anything. Normally, we do around 40 to 50 minutes presentation, but if you need more time, it's not a problem. And then after that, we go for some time for questions. Thanks a lot.
Okay, thank you, Anderson, and hello everybody who's listening in. It's more than 20 years ago since I was in Rio. I visited COP in Rio. I have such good memories of it, and I keep saying, and actually just a couple of days ago while meeting friends and comparing the beauties of the world, I keep saying that surely Rio is the most beautiful city I have ever seen. So I have such good memories of it. You are all in t-shirts, but I have a woolen sweater here. We got some snow today in Kent. Kent, by the way, is about, or where I'm sitting is about 100 kilometers south of London. But we have wintry weather here, so we're all inside. I'm going to talk today about a fairly general topic on AI and a critique of AI. I haven't done that for a long time. I am a mathematician and I have worked for 35 years on AI and really always on the technical aspects of AI. I started working on backpropagation and improving backpropagation. I've done work on self-feedback of neurons. And so I feel very at home with the current research on deep learning technically. But I feel that certainly in the last 5 years, there has been a critique of AI here and there, not much, but there has been a bit of critique of AI. And I want to give you my own view on that. I think having done neural network research for 35 years, I have somehow earned the privilege and also have the historical perspective of looking at pros and cons of AI. Most people that I meet have have joined AI and have done AI research in the last 10 years. So they have joined AI in the last 10 years and they have seen continued growth of AI. If you have a longer perspective, 35 years, for example, this means I have also seen one of the AI winters. I have seen, for example, the collapse of expert systems in AI. I have also seen a number of other collapses, statistical physics-based AI, for example, spin glass neural networks. I have seen the collapse of that, and of a number of other specialities in AI. So if you have joined AI in the last 10 years and have seen this amazing growth, it hasn't always been that way, and I'm sure there will be fluctuations in the next 35 years. So that's what I'm going to talk about. It's a fairly general talk. I will make some technical comments. It's about big AI. It's about a critique of big AI. It's also about small AI, which may be newer to you, but I will explain what that is. I want to start with this quote. This comes not from an AI specialist, but from a cryptographer in France, and it's just 2 months 2 months old, really. This is a lady, a French cryptographer, who decrypted a historical document that was 500 years old and was written in a code. It was a diplomatic document, safely encrypted, and she managed to decrypt it. And actually, if you look at the detail, it's not obvious at all. I think she did good work. But what struck me when she spoke to the press was that she said, I did not use artificial intelligence. So she felt that this was something she did have to say about her research. And indeed, when you look at recently what sort of things are called artificial intelligence, I would say more and more research, more and more techniques are called artificial intelligence or call themselves artificial intelligence. For example, a lot of statistics currently is calling itself artificial intelligence, and I will comment on that later. Also, a lot of what are really just algorithms, for example, algorithms for social network analysis, are often called artificial intelligence, or any social network analysis is often called artificial intelligence. And I have no objection to that. I just want to observe that as AI is growing and becoming more successful, as I would say, the core AI, let's call it deep learning for the moment, as the core AI is growing, more and more things that are not core are sort of swept up in this growth, and are also keen to label themselves as AI, but not this French cryptographer. And I think it's interesting. So she could easily have claimed that she used some AI technique. If you look at her work, it's clear that techniques like transformers, for example, could play a role in cryptography, and she could have claimed to have used something like that, but she didn't. She wanted clearly to say, this is not AI. This is just an opening remark, a little bit deeper, but also based in France, is not a cryptographer, but a psychoanalyst called Félix Guattari. And he worked on psychoanalysis, also on sociology. He had very wide interests, and he's highly regarded, not just in France, but in what I would call the European or the continental philosophical school. Guattari is highly regarded by them, and I'll tell you a bit more about his ideas. But towards the end of his life, he wrote a little booklet, very brief, where he introduces something called the three ecologies. And it's been translated in English, but I'm sure if Portuguese is your mother tongue, you know enough French to understand the title, and probably a lot more of what is being written in France. The three ecologies is something that was entirely new in 1989, apart from a Norwegian philosopher called Arne Naes, who was also working on a wider and more holistic view of ecology. And I think this is relevant to AI, and that this is one of the things I'm going to argue during this seminar, that the views of Guattari and Naes on a holistic view of ecology are relevant in looking at artificial intelligence and in looking at difficult issues in AI, and also looking towards solutions for AI. So let's look at a little bit more detail what this is about, the three ecologies. It's really about three types of ecosystems. And here at the top, let me see, I have my cursor here, yes. The three types of ecosystems are as follows. You have environment here. You have society, and you have human mental health. And I'll elaborate on that in a minute. But Guattari said, if you look at ecosystems, you should not look only at environment. There is more to it. Let's start by defining what I mean by ecosystem here. Ecosystem, well, this consists of connected components, in general, very general, because we're talking about ecosystems in general here. So connected components, and they are subject to competition. So these components, they compete, and they may come and go. So there is a kind of evolution happening, and the evolution is controlled by competition. This is very Darwinian, a Darwinian view of looking at an ecosystem. And these components are at a certain energy level. And energy can mean a lot and means different things. I'll be more specific about that in a moment. But so that's our very general definition of ecosystem. It's connected components competing, and they all have certain energy levels. And these energy levels determine the success they have in competing, and they may vary over time. So now let's look at these three ecosystems: environment, society, and human mental health. First of all, there is environment. And of course, environment, you of course think in the first instance about biological environment. And again, thinking about Brazil, I have such good memories of the Mata Atlântico and walking through that. And I hope you're taking good care of your local biological environment. But computers are also part of our environment, and we're talking about AI after all. So you can define computers as part of our environment, and these computers are selected by market forces. So what we use, and that can be mobile phones as well as laptops, or can be cloud computing that we choose to use. So the computers in our environment are subject to market forces. Things come and go, and there is a price to pay if you want to hire some time on graphic processors or on tensor processors. There is a price to pay, and these computers consume power. And that power can be very low if we're talking about mobile phones. It can also be enormous if we're talking about large models and models with billions of parameters. I'll be more specific about that in a moment, but this is just our definition of the first ecosystem, the environment, and we're going to look specifically at computers and the market forces that play and the power they consume. A second ecosystem, and that's actually not too different, and that's one of the contributions that Guattari made. A second ecosystem is society itself, and the connected components in society are the people. So we are connected, and AI plays a role in connecting us, and I'll be more specific about that later. And we all struggle to survive in our societies where we are. And I just read the news item of another Iranian protester being hanged, and I think that is terrible, because the protesters in Iran for the moment, they are literally struggling for their life while they protest. But all of us really, at a certain degree, struggle to survive, but some of us are much more comfortable in that than others. And we consume resources to survive. We consume resources, food, heating, but also we consume computing resources, because we are connected. And as I say, we are connected, and AI plays a large role in that, and that also consumes resources. And whether it's us or the protesters in Iran, we are all connected via IT, and we consume resources. Thirdly, the third ecosystem is mental health. And this may be more new to you, and you may not have thought about mental health as an ecosystem, but Guattari, who was a psychoanalyst, very much, and actually when he thought about ecosystems, mental health was the first system he thought about. And mental health is an ecosystem as follows. It's the connected components there are the cognitive processes that are happening simultaneously in our brain. So we think about several things about the same time, and we have background knowledge and we have foreground cognitive processes, but a lot of processes are happening at the same time. Most of our neurons are active all the time, even when we're sleeping and dreaming or not dreaming. Whether we do a very simple cognitive task, like recognizing a color or a character, or whether we do a very complex cognitive task, like thinking about our career progress or something, our neurons, they're active most of the time. So there are lots of cognitive processes, large and small, happening in our brain. And as I write here, they are embodied in the brain. So they all have to operate in our brain. And of course, our brain has lots of neurons, but it is limited. Our brain is not infinite. So the cognitive processes, they're all somehow crammed together in our brain, and they're competing for attention, for our attention. They're competing for success in the brain. And they do that to a certain degree, a certain self-awareness. I won't go too much into the detail of the energy levels of the cognitive processes we have in our brain, but they are they are very real. And with fMRI, for example, with brain imaging or MEG, you can look at the energy levels of different cognitive processes. So that's Guattari's view. Here you have these three ecosystems, and I think at this point, it's probably not clear to you what this has to do with AI. So I'm going to elaborate on that in the next couple of slides. But we have a holistic view of looking at ecosystems, at the environment, at our society, and at our mental health. So let's look at a little bit more detail. Let's start with the environment and computers consuming power. I think that's the easiest, the easiest way here. Computing consumes 5 to 10% of the world's electricity. There is a wide range in the estimates, and there is a good reason there is such a wide range in estimates, because it depends a bit what you include. And I'll come back to that in a minute. Computing, there is lots more to computing than the actual cost of electricity usage. Although if you look at it, and if you read the AlphaGo papers here, that's DeepMind, mentions a training cost of 35 million of one of their large models that appeared in Communications of ACM in December 2020. So that's an overall training cost of one of the AlphaGo large model. And DeepMind has a number of large models, more recently folding of proteins with training costs of this order. More recently, Microsoft has said that they spent $50 million on a single training run of a large model. And as you maybe know, these large models used by Microsoft and Google, they need to be retrained regularly because they are trained on a corpus which contains lots of recent things. For example, after the Brazilian elections, if you want to give sensible replies in a large model, you have to retrain it to know the latest. So a lot of large models have to be retrained all the time. And I think here the data from Microsoft, $50 million for one training run, says a lot and gives you an idea of what a company like Microsoft is spending on training. Now, as I said, there is a wide range on what's included, what's not included in AI and in large models. And from the very basic level, sorry, I skipped here. From the very basic level, you can actually look at mining minerals. And there is somebody called Kate Crawford who recently published a book called Atlas of AI. And she elaborates on that quite a lot, on the actual cost of mining the minerals you need to have AI applications. I'm not a specialist in rare earths, etc. I'm sure Brazil has some, or Chile, but there is a cost. There is a cost of actually building computers as well, of just fabricating the microchips. And then not to forget the cost of the mechanical Turks, who are not mechanical at all, but to generate large labeled data sets, this is done by people. Yeah, this is done by thousands of people, for example, via Amazon's Mechanical Turk, and they get paid for it. And that adds to the cost of training runs of large AI models. So it's a human cost of people who have to be paid, people often working in not great working environments. I've seen some pictures of where these Mechanical Turks are. I mean, some are at home, but some are just in batteries really packed together in large rooms. So there is a cost there to the environment of not only consuming electricity but also consuming human resources for training large models. The growth is driven by transformer architectures. Recently you have GPT, you have BERT, and this is the models themselves are growing in size. Recently there is a model now that's very popular or becoming popular with students to write essays, and I've seen some of the first essays. I'll comment on those in a minute, but clearly transformer architectures are driving the growth. They're very large. Basically larger is better, and now also being used for image processing, and I'll show you something in a minute of transformers for image processing. Again, larger is better there. It's not just transformers that drive growth. There are graph neural networks. They don't scale well on large graphs, and that means they are incredibly computing intensive. If you want to do analysis of large graphs, and this can be all sorts of systems, social networks, other graphical systems, for example, protein interactions. If you want to use graphical networks, they are incredibly power intensive. So basically, I would summarize this environmental aspect of AI, that the trend is for larger models, and they're often run on corporate computing facilities. I see a lot of academic labs basically giving up on larger models and on giving up on research on large models, and essentially leaving that to Google, IBM, Microsoft, etc., running these enormously costly larger models. I'm uncomfortable with this evolution, and that's why one of the reasons I'm giving this talk and I'm looking in these things. I and a number of other people are uncomfortable because we don't know where that ends. And you could see a world where computing is taking up a larger and larger amount of human resources, and often for smaller and smaller gains, or smaller and smaller utility to the users. And I'll come back to that in a minute. Let's first look at society as an ecosystem. How is society affected by this increasingly larger scale AI? Well, what we see is that communication gets faster and faster, and we have more and more pop-ups and alerts on our mobile phones, on our computers, and that leads to an increased socialization. So we are in contact with more and more people via Twitter and Instagram, etc. And we are in contact, but with a higher intensity, because we get more and more communications, and the communications want to have an impact quite fast, within a couple of days. Because if you look at how LinkedIn prioritize your communications, they have a short half-life. They go down quite fast. We know from research like Christakis that social contagion is faster if there is more connectivity. So if you want to influence people, the higher the connectivity, the faster this is going to happen. This is somehow self-evident, but just to say that there is very serious research behind this. This is not just an intuition. The social contagion and the spread of behavior in society is becoming faster and faster. A third point I wanted to make is that social networks are not peer-to-peer. Algorithm designers of social networks are dominant participants. And one of these is my daughter. My daughter works for Instagram, and she's one of these algorithm designers. And talking to her, it just becomes very, very clear to me what an important role these algorithm designers have in social networks. They really control, and you will have heard about experiments that Facebook did with prioritizing certain posts and hiding others. But whether it's an experiment or not, the algorithm designers in Google, in Microsoft, Facebook, etc., Twitter now also, are playing a very important role in social networks. So there is no democracy at work there. Algorithms steer social contagion. So whether people buy something or not is the result of algorithms and is the result of AI and of true AI, I would say. Again, in society, there is fake news, you know about that. I think there is a continuum between 100% honest posts and 100% fake posts. It's not so that something is either honest or fake. There is simply an enormous gray zone of things that are just being influenced by serious fake or serious conspiracy theories, but that have also a half honest component. And it's often these messages which spread quickly because and spread in a large audience. And this is generated by either by humans or by bots. So that's another aspect of the current AI-driven socialization of basically how society is influenced. So by a large number of messages that circulate fast, that are controlled by algorithm designers, and where honest and fake is often hard to distinguish. Finally, I want to point out that in our AI-driven social world, there is no consensus mechanism as in a true democracy. A true democracy, of course, is an ideal thing. It of course doesn't exist in reality, but you could imagine a democracy where whenever a new behavior or a new idea is spreading, people come together, everybody comes together and discusses it, and discusses its pros and its cons. This is not happening because everybody now, because the social networks are on such a large scale, it is not possible to have a discussion with everybody engaged. And so there is no consensus. There are some consensuses that are generated artificially by algorithms, but again, that's part of the manipulation mechanism. But what we are seeing in the current AI-driven society is that there is no consensus happening. There is no fully democratic consensus. So as a conclusion, really, I would say that the internet is a parallel society steered by algorithms, and I feel pretty uncomfortable by that. And I think a number of people feel uncomfortable. Finally, mental health. So AI is actually adapting our IT environment by creating bubbles. You will know that. So the bubbles around us are created by AI. AI wants or makes us want to respond within our bubble. Yeah, so it wants to be engender activity within a bubble. And a third point, which is different from the two previous ones, is that AI blurs the distinction between artificial and real. So if you go and watch the next Avatar film, I think you will have that conundrum in finding where is Kate Winslet amongst the avatars, and how the facial expressions you see, how real are they, how artificial they are. Generally, a lot of science documentaries have a lot of computer graphics in them. So we live in this world which increasingly has more and more artificial parts to it. And of course, the metaverse of Facebook will have us operate in a world with a lot more avatars. If you want to see what that is, here is, so this is stable diffusion. This is one of the large models like DALL-E generating pictures. And this is what it makes of me, of Philippe De Wilde. So you see man on a horse here, although I have never driven a horse, but that doesn't bother me. It's the fact that where is this leg of this horse coming from, for example? What's happening to this hoof of this horse? Look at the face here. I don't know if you have seen pictures of Francis Bacon, an English painter. That's a sort of the faces, the paranoid faces he painted. This is a horse rider with shorts, which is not normally the way you ride horses. There's something wrong with the tongue of this horse. And this is very much the reality that AI is creating, whether it's images or whether it's text coming from BERT or GPT. It is a kind of paranoid reality where there is actually very little logic. And so Timnit Gebru from Google, you may have heard of her, or who used to be at Google, coined the term stochastic parrots for the large models. And I think that's very much my feeling when I see this picture of myself, and you should try it, of yourself as well. You see a fairly random environment that is nevertheless credible to some extent, and that draws you in. And somehow that worries me, because in the metaverse, if we're going to be surrounded by people like this horse rider, this would affect your mental health. So this was my third point, AI affecting mental health. I'm going to speed up a little bit, if you don't mind. And I'm going to talk about 3 solutions to this, because I'm not the first one to notice these things. Solution 1, I would deem pessimism. And it's actually, it's personified, I would say, by somebody called Joseph Weizenbaum, who created this dialogue system a long time ago, already 1966, a very primitive dialogue system, but people started to take it for real, and it's still around. You should try it. And he started to reflect on it and essentially said exactly what I just told you about DALL-E and about these transformers. He started to reflecting on his ELIZA system and said, what world are we creating if people take these fairly random environments for real? And a lot of his critical reflection on AI, and a very pessimistic critical reflection, is about that, is about a world generated by transformers and by the stochastic parrots, and what effect does it have on our society. There is also a more philosophical reflection. I'm going to skip this, I'm afraid. I just wanted to mention such an important Latin American philosopher and educationalist, Maturana, who worked on this as well, and who looked at pragmatist hermeneutics read up on it if you haven't heard about Maturana, but he did reflect also in a very pessimistic way about AI. So very briefly, this is a first way of, I think, solving some of the problems in AI. A second way is the law. And this is the slide is a brief summary of legal approaches to regulating AI. And in Europe, for example, Europe always strong on regulation and on essentially stopping innovation. I would say they did that with microelectronics. They do it with AI now. So the proposal is to ban certain parts of AI, such as social scoring, something that's popular in China, also real-time face recognition, and the distortion of human behavior. That is the AI Act proposed as for the moment. In the UK, just to remind you, the UK is not part of Europe anymore. We have left since Brexit. UK takes a decentralized approach implemented by existing regulators. So nothing much new really, and says it's going to be pro-innovation. There is a proposal currently going. USA Algorithmic Accountability Act, you can read up on that. I would say this is going nowhere for the moment, is somehow stalled somewhere. There is an AI Bill of Rights, actually for the rights of the human users of AI. This is only at the blueprint stage. And if you look worldwide, actually the only country where there is an actual law that's actually operational is China, where they have something called the Provisions on the Administration of Algorithm Recommendations for Internet Information Services. You can Google that and read up on it. It is a law, and I think it's a very serious piece of law. And also we know in China, if you break the law, things are very serious indeed. And so I think this is the landscape currently. So I couldn't find anything about Brazil. I'm afraid you may well know the state of affairs in Brazil. It's probably closer to the USA and the UK than it is to China. It is a solution, so just throw the law at it if you're unhappy with something. As you probably know, this is a very slow solution, and for the law to really change things, I think you're probably looking at a succession of laws, a succession of governments. You're probably looking at 20, 25 years. This is much slower than the evolution in AI. Solution 3, I would call, is keeping up hope. And you can see that at Google. Google has AI for social good. That's a project involving lots of data, as you would expect from Google. I'm just picking up out a few people here. There are more. There is Stuart Russell, who works on human compatible AI. He writes books. Stuart Russell, by the way, you know him from his textbook on AI, Russell and Norvig, is used by you may well have learned AI from him. But he also works on increasing human control in AI. He's a strong advocate of that, reducing harm. There is the AI Now Institute. You have people like Kate Crawford. There are others. There's a big turnaround there. I think they don't have much money, so people have to leave after a while when the money runs out. I think an interesting institute, New York University, looking at the power relationships between companies and users. One thing I want to say before I come with solution number 4, which is more my own contribution, is that all these hope prophets, as I would call them, they're all pretty close to big tech, really. Stuart Russell is in Berkeley, PhD from Stanford. Kate Crawford also in California for the moment. So a lot of people who will tell you it's not that bad and we'll fix this. Have a look at who's paying them and where their affiliations are. I want to come now to the final part. I think these are 2 or 3 slides I have of another possible solution. This is again inspired by a book, and again a fairly old book. It's by an economist called Schumacher. And he looked at technology and humane technology. And he proposed that a while ago, but I think this is relevant for AI. And I just want to introduce that briefly today. Schumacher worked in 1973, and around that time, essentially post Second World War, he focused on energy and the awareness that resources are finite and the awareness of pollution. That was 1973. I think this is still very, very current across the world, and certainly among the young people of the world. There is lots of hope there, that there is this awareness of finite resources and of climate change and what we need to do. Schumacher introduced the notion of intermediate technology, appropriate technology, also related to self-reliance. And I think there's a message in there for AI. We don't have, I will argue for the next 5 minutes, we don't necessarily need to buy into big AI and the costs and the damage to the environment and to society and to our mental health that big AI is doing. We could actually scale down a little bit and look at the intermediate technology that Schumacher proposed. This is related to a number of actual technical contents, and I won't go too deep into here, but actually there is a lot of maths behind scaling down. And I just want to point out 2 things briefly. There is Occam's razor, you may have heard about that, saying that a model with fewer parameters is actually a better model. Now, this is not the way that transformers are going, because transformers, the philosophy there is the more parameters, the better. And they had millions, and now they have billions of parameters and the concomitant energy use. But I think it's worth going back to Occam's razor and looking at why this is proposed. I won't go into detail for that, why fewer parameters are generally preferred. And the other is small systems. There is a bias variance trade-off in statistical models, and I come back to statistics on the next slide. And that suggests that actually there is an optimal number of parameters. And you derive that from concepts like the Bayesian information criterion, the Akaike information criterion, and there are 1 or 2 others. As I say, these things, Schumacher, intermediate technology, Occam's razor, looking at bias variance trade-off, go against, are opposed to the current big models, the deep learning, where currently they've invented something called benign overfitting, which basically says, well, you have billions of parameters, you're going to do massive overfitting because of these numbers of parameters. Well, it's not a problem. So you can see that that research is coming out in the last couple of years. It's not a problem. You just keep growing and growing and growing your models. So my slide here, and I think this is the most practical slide related to the solution 4 of the problems of AI, and it's a little toolbox for simple AI, and that's what I want to come down to. There is, I think, worth looking at. Hasti Tipshirani have written 2 books on what they call statistical learning, and this is machine learning, but very deeply rooted in statistics, and hence very interpretable models. Andrew Ng, one of the inventors of deep learning, really, is scaling down himself now, and he's looking at what's called data-driven AI. If you look into that, you will see this is about small models. There is the movement of tiny ML, which looks at AI at the edge, so AI in small processors, again scaling down. There is research on what's called one-shot learning, few-shot learning, or also now called frugal AI. Even the defense community has picked that up, frugal AI, so smaller AI models. And this is an old nut really, neural symbolic integration. But if you can introduce rule-based systems together with artificial neural networks, potentially you can reduce the parameter size. So here is, and this is my next to last slide, this is my sales pitch really for my solution 4, although I recognize the other solutions as well. Small AI can be energy efficient because it has much less parameters. It's transparent and interpretable because you go back to statistics. If it's interpretable, it's more open. If it's more open, it will fit in better in democratic processes and create trust. It's a simpler environment. It's intelligible to all abilities. AI should not be just intelligible to you and me. We all have degrees in computing. It should be understandable to everybody. Just a warning here, for simplicity to work, it may require reframing. For example, self-driving cars, where again, everything is getting bigger and bigger and bigger for the image recognition. You may need to reframe to make simplicity work. And there are a few more caveats here about how to centralize. You may need to have more true peer-to-peer networks. And finally, going back to the power consumption of simpler systems, you can actually have them powered locally. For example, powered by the movement of people, by the wearables, or by the actual people walking around. So basically, that is it. I've told you that big AI creates problems in 3 ecosystems: in the environment, in society, and in human mental health. I think some solutions are not that practical, namely just being hopeful or saying it's all bad. I think legal solutions are certainly there, but they are going to be very slow and probably too slow for AI. And I want to invite you to also have a look at what I call small AI. It's this statistics-based AI. I've given you a little toolkit for that, and I just want to commend it to you as not the only solution, but I think setting a step back may well make all the users of AI just a little bit more happy people living in a more sustainable environment. Thank you for your attention. That was my my talk. I'm going to stop sharing my screen if I can.
Sure thing, thank you. Let me put myself also in the spotlight so it makes things easier. All right, so it was very nice to see this presentation of yours, and while you were presenting, I just got 2 recent books that I read, and they are totally aligned with the stuff that you mentioned here. The first one is The Political Philosophy of Artificial Intelligence. This was written recently, 2022, by Mark Zuckerberg. And the second one is by Ben Schneiderman, Human-Centered Artificial Intelligence, AI that we focus on the people, as just as Professor Philippe De Wilde mentioned to us. Also, from this year, 2022. So I recommend these readings and the pointers that Professor Philippe put here. And I would like to start this discussion asking your opinion, Professor. You mentioned 4 possible solutions for the problems that we have. We have many other problems, but according to the outline that you gave, we could be pessimistic. We could rely on regulation or go after law. We could just believe the big tech and just believe the optimistic way they sell things and they pitch things. Or we could put humans in the center of it all, just like the economics, if people mattered. So what's your personal take on this? I would say that we would need the four of them, a little bit of each, depending on the situation.
I certainly think we are all humans, so it's kind of self-evident that we need to put humans first in this world. And I think if you put humans first, and as I say, all humans, not just those with a PhD in computer science, if you want to put all humans first to have a good relationship with AI, you need to make AI more transparent and simpler. Just having a little, or having big things, generating random environments like the metaverse with avatars, or like pieces of journalism generated by GPT. This is inhuman. This is not humane. The vast majority of humans can only cope with a simple environment, and that's just how it is. We need to simplify, and I think that's where big AI is just going completely the wrong way.
Exactly, I agree with you. We have some questions in the chat. The first one is, do you think these expensive data-hungry models could be regulated?
I think regulation will fail. The way I follow the EU and the UK regulation, the attempt, because I say it's all proposals. For example, they have been completely taken aback by transformers and by GPT, and I actually can give quotes from European politicians who said, "We didn't see this coming. Quick, we need to regulate this as well now." But transformers will evolve, and I see the law being way too slow. And although I'm highly critical about how the Chinese deal with the internet, actually, I have respect for the fact that they put an actual law up pretty quickly. And if you look at their law, it's very much about consumer protection. And they have Alibaba, which has quite a unified environment where people can buy, but also bank and so on. And I can just see the Chinese seeing the danger of that and quickly putting down a real law. So I have, as I say, it's very little, but I have some respect for that. And I think the lawmakers, if they are to be effective, they will have to be much, much faster than they are now. And I think the whole legal system is not geared towards speed. It's very slow. Well, you have great experience in Brazil with presidents being pursued by the legal system. And if you look at the time scale, you can just see this is the wrong time scale. So suppose you had not Petrobras, but you have sort of AI brass doing something wrong, but if it goes with the same speed as the Petrobras legal investigation, that would be way too slow.
Yeah,
so that
exactly.
wouldn't work.
I have one curiosity. You mentioned these stochastic parrots, which is a very nice definition. And we've seen this week that we have the release of ChatGPT, in which you can talk to it. And one of the things that I've seen and I've read about it is that some students are just going after it to do homework. And it's kind of a problem because they just ask to the ChatGPT the questions that the professors, the teachers gave them, and there is no reference, and it's just a combination and repetition of things.
How do you see these kind of technologies influencing education in the wrong way?
Yeah, I've written a column for that for European magazine, and what I argued there was the following. I think this stochastic parroting for essays, I think this is what a lot of students have been doing all the time, namely quickly reading some material and putting it together in a random way. And I would say not just students, but also some researchers, because we all have to publish more and more research papers. And again, in my 35-year career, I can see now, like I used to be at Imperial College, and the researchers there now publish 20 papers a year. That's the sort of tariff. When I was at Imperial, I would publish like 3 papers a year. So I see a lot of researchers putting together things like a stochastic parrot, poor quality papers. I see a lot of students writing essays, poor quality things thrown together, but not with GPT. So I think GPT is just automating something that has been happening a long time. And I think the only solution is actually to read the outputs. If you're a reader of a research paper or a reader of a student essay, you need to read the whole thing and look for the logical reasoning, because it's the logical reasoning where GPT is failing. And you need to look at clues of logical reasoning. And that's why, if I can mention or answer also a remark that Philippe has made about neurosymbolic processing. And Philippe, a very good friend of mine, by the way, but he mentions neurosymbolic processing, and see if it's the symbolic part where the transformers are so poor, is the logical structure where they are poor, and I think will remain poor. And I think potentially smaller models that are neurosymbolic could have a lot of value, could actually produce a lot of valuable stuff, maybe not student essays or maybe not fake research papers, but just small hints, let's say, to help researchers or to help people who are writing. So it again, I think, points towards smaller models that could include some symbolic reasoning.
Nice, thank you. From Leopoldo now, and Felipe, thank you for joining us as well. Leopoldo is saying, thank you very much for the lecture, Professor Philip. Always a pleasure to hear from you. Do you think that increasing our own understanding of the biological learning process could also be a possible solution to the big AI problem, given the energy efficiency of the biological brain? It seems difficult to me to have solid epistemological foundations that allow us to have a holistic understanding of the neural networks without advancing understanding of complex systems, since we currently cannot produce a robust theory about how the emergent properties of networks impact their learning. VC dimension and other attempts are just as naive in this regard.
I agree with Leopoldo that VC dimension has been very naive, and I think it was well intentioned. A lot of the computational learning, PAC learning, and so on, it was well intentioned, but it has become a branch of mathematics now, and I think is not relevant for the kind of systems we currently work with. Should we understand the biological learning processes? I think absolutely, and there is an enormous gap if you look at the current neuroscience. I mean, not computational neuroscience, but just plain neuroscience. There is so much to be understood or about consciousness, but also about levels of attention, and, as I say, the different processes in our brain that compete. for energy, basically, for literally for oxygen in our brain. There is so much still to learn. I think we are nowhere really in neuroscience, and I regret that. Like with deep learning, the last 10 years, you see enormous progress. And although I criticize it, technically I have respect for the progress. When I read the neuroscience literature of the last 10 years, and I think an enormous investment, but really very little progress. And I don't blame the researchers. It's just clearly an enormously hard problem, and I think it would need a lot more investment. We know so little.
Exactly, I agree with that. There are two big projects, one European and one American, about $1 billion each for like 5 to 10 years. And people say that we didn't advance enough, but I think we did. And the problem is that the problem is very, very hard, right?
I know the European project to some extent because I followed Harry Markram, who originally led that and then came in for lots of criticism. I followed him because he was very much computational neuroscience. And that was the original slant he gave on it. And then he got lots of criticism from what you could say real neuroscientists saying, this is too artificial. And I think they were all right, and they were both right, and I see very little progress in that European, and it was advertised as a moonshot program, but my God, where the actual Apollo moon program, you had engineers, you had regular progress. This European brain moonshot is nothing like, it's all over the place. It's a kind of general, I think it's
umbrella.
become a sort of mini CNPq, funding little projects here and there, but it's not a moonshot. There is no rocket at the end that will deliver people to the moon.
Great. Philip is acting as a provocateur now. And Philip, my wife is a lawyer, and I keep discussing with her this question of yours. The effectiveness of legal treatment of AI in face of the speed of AI advancements. Very good point. What about having AI to help legal regulations to be updated on similar pace?
Sure. I have to declare a conflict of interest here. I mean, apart from this sort of philosophical reflections, I still do technical work, and I actually work with a law company who is looking at legal cases and who wants to classify them better. They look at medical negligence legal cases, and I'm working with them to classify them better. Yes, I think absolutely. And now the way I work with that law company is very much the way that Andrew Ng is currently working. So he also has this consultancy and going down to smaller data-focused models. And I'm working with my legal company, but also with a statistician, and we're looking at fairly small models which we want to make transparent so that the lawyers actually can understand our classification. So yeah, I think that, yeah, that's certainly feasible. But I think the sort of legal things on a countrywide scale or on a Europe-wide scale, to actually restrict AI, I think are fundamentally well-intentioned, but are just way too slow.
Thank you. And the last one, just a provocation as well. You live in a strong democracy, and you've probably read that we've been through like several challenges to our own democracy here, but thankfully Lula won the elections, and it seems that we are going to go on a good path forward now. But many people argue that AI can be used and is being used to like attack democracy and to like weaken democracy. How do you see these, and what we could do to use AI to strengthen democracy instead of the contrary?
Sure, the people around Donald Trump, there are AI people around Donald Trump that have used algorithms to weaken society. And there was the scandal with Cambridge Analytica as well before that, who also were giving solutions to politicians to manipulate society. First of all, a comment on this strong British democracy. There are, again, I think it's a matter of degrees, and still, in Britain, for example, we have a system called first past the post. So we don't have proportional representation. So it's a possibility to have a majority in parliament with only like 30% of the vote across the country. So there are still, I think, possible improvements to the British system. But what I do notice is the British democracy being less vulnerable to the spreading of fake news than I have seen in the US, and also have seen in the latest Brazilian elections. I was taken aback by how the general population believes and is influenced by fake news. In my view, it only shows that when we develop AI, we have to take into account the average person who just doesn't have a degree in computing, or is way below, and actually may struggle to understand anything at all about how influence works, and how influence works via their mobile phone. Large majority of people don't understand that, and I think we need to reach out to them. And I think academics, we need to in a way, we need to admit, I think, a lot of academia has been too elitist, developing solutions for an elite. And it's certainly true if you are well educated, if you're well educated, but you don't understand computers, then you're still robust against influence by fake news. But if you're not well, I think we academics, we have been working too much for an educated fellow elite, and it's easy to talk to them. When I talk to my students, and I teach ethics, I also teach bioethics, and I tell them, don't just talk to your fellow students, but dare to talk to people who disagree with you. And I think we need to, as academics and
very good.
We need to dare to talk to the people we don't like at all, the sort of the followers of Trump or Bolsonaro. We need to put effort in talking to them and educating them.
Thank you very much. Very good points. And it all ends with like human-centered artificial intelligence. Very good points. Professor, once again, thank you for accepting our invitation. Thank you, Felipe França, for joining, Leopoldo, my former student, Fabio Faria here, and everybody in the audience. Thank you for joining. And Professor Philip, stay safe. Thank you very much.
It was a pleasure. And again, my greetings to everybody there.
Thank you. Bye-bye.
Bye-bye.